Welcome to Spring LIB.
Answer to chapter 30, problem number 36 from the Smith Organic Chemistry textbook. And so this problem is describing a steroid molecule to it and asking us to draw it based on that description. And so for A, we're given just a very basic description. For B, stereochemistry is then added to that description. And then for C, we're asked to treat the molecule that we've just drawn with an acid chloride and pyridine, and to then draw what the resulting product would be. So I'm going to combine A and B here. So I'm just going to draw this molecule with the stereochemistry from the beginning rather than drawing it and going back and erasing things and redrawing it. And so the very first piece of information that we're given is that this molecule contains our standard tetracyclic steroid structure. So it's ugly. So the first thing to do is going to be to draw in those 4 fused rings. I'm going to redraw that. So there are our first 2 6-membered rings. Then we have a third 6-membered ring coming off there. And then off of that 6-membered ring, we have a 5-membered ring fused. Okay, so that's the basic structure of a steroid molecule, the tetracyclic ring system. So the next piece of information that we're given is that there's a carbonyl group at C3. And so we can go ahead and remember, we're going to start numbering from here. So that if that's 1 there, 2, 3. So we have our carbonyl here at 3. The next piece of information that we're given is a hydroxyl at C17, a double bond between 1 and 2, and methyl groups at 1, 10, and 13. And so, and actually, so I said that wrong. So this carbon here would be carbon 1. And so again, if that's 1, the next one's 2, and then so our carbonyl is in the right spot, but I started counting from the wrong position. So there's a double bond between 1 and 2. We were told that. We have a methyl group in the R configuration right here. So we can go ahead and draw that in. We have a methyl group here at carbon 1. And so that's not going to be dashed or wedged because remember, you can't have a chiral carbon if it's sp2 hybridized as this carbon is. And so we can go ahead and draw in the other pieces of information that we've been given. So another methyl group here with the S configuration this time is going to result in being wedged again. A wedged hydroxy group here. And then we're told that all the substituents at ring fusion positions are trans to one another. So we can go ahead and indicate that as well. Let's just double check. That's methenolone. So that fulfills A and B. So I'll go ahead, just put A and B there. Okay, and so then we're asked to draw the product after treatment with this acid chloride here. So the one they want us to use is CH3. And then is it 5? Yes, 5 CH2s. And then the acid chloride and some pyridine. Okay, and so basically we need to look at this molecule that we've drawn and see really what that acid chloride can react with. And there's only one apparent functionality here that's really going to be reactive towards an acyl chloride, and that, of course, is the hydroxy group. Oof. So the only thing that's going to change from methenolone to primobolan is that we're going to esterify that alcohol. So we can go ahead and the tetracyclic ring system isn't going to change. So there's our tetracyclic skeleton. Our carbonyl group here is going to be unaffected. The double bond will be unaffected. All of the methyl groups obviously won't react. Okay, and so now we come to the part of the molecule that is going to react. And so we had a hydroxy group here, an alcohol, and so instead of the alcohol, we are just going to have an ester now. We've esterified the alcohol, and so 5 CH2s and a CH3. And so that is primobolan. And so that's what we were asked to draw for part C. And so there's part C. And that's the answer to chapter 30, problem number 36.